Hello and welcome back. In our last video, we discovered how essential rocks and minerals are to our everyday lives. Virtually everything around us is made from the minerals that we extract from the ground. Metallic ores are mined to provide us with the metals and alloys used in items such as phones, computers and cars. Oil and coal have been relied on for many years as a source of energy, and their chemicals are used in industry. You might be surprised to realise just how many products are produced from oil. If we take just 1 barrel of oil, it can be used to produce enough fuel to drive a medium-sized family car for more than 280 miles. It can also provide the fuel for a large truck to travel 40 miles. It can produce enough wax for 170 birthday candles. 1 gallon of tar can be produced for repairing roofs and streets. 70 kilowatt hours of electricity can be generated by a power station. Liquefied gas can fill 12 camping gas or barbecue cylinders. There would be enough petrochemicals left to provide the base for 540 toothbrushes and much more. So we know how important the rocks and minerals are that cover our earth as a source for the building blocks of everyday items. But it isn't just modern high-tech industry that mine for minerals. For thousands of years people have searched for minerals, and how do they go about finding these resources? The process, referred to as prospecting, can be as simple as looking at the surfaces of rocks. Here we can see prospectors panning for gold. The photograph on the left was taken in Alaska, while the one on the right in New Mexico. As you can imagine, covering a large area on foot to look for rocks containing minerals would be slow and time-consuming. But with advances in technology, more modern methods often involve remote sensing. This could be the use of aerial photographs or satellite data and images. Through remote sensing, large areas with potential rocks containing minerals can be identified quickly. Geologists can then visit the area to confirm the findings by performing a field survey. They will obtain samples of rocks which can be taken for geochemical analysis, allowing rocks which contain enough of an important element to be identified. Another method used to identify mineral ores in rocks is geophysics, which looks at the physical properties of rocks. Here, a series of vibrations are sent through the Earth's surface. The reflected vibrations are detected by sensors. The reflected waves show different patterns depending on what minerals are present in the rocks, and geologists can analyse the data to identify ore of interest. Okay, so the geologists have identified sites with rocks which contain minerals. Do they dig them all up? Not necessarily. First, they do a resource evaluation. They want to know how much mineral there is in that location. Is it good quality? How feasible is it to extract the mineral? How much will it cost to extract compared to the value of the mineral? If there is enough mineral of good grade, the deposit may be classified as a mineral ore reserve. Whether it is mined straight away or not depends on how easy it is to access and how much money the deposit is worth. Some factors which affect the viability of extraction include the cost, the local geology, the climate in the region, accessibility to the site, the environmental impact, and the value of the resource, which is influenced by supply and demand. When geologists have identified a mineral ore reserve which they are going to extract, there is a large enough volume of good grade mineral. Access is deemed suitable and the value of the mineral is greater than the cost of extracting it, making it a profitable exercise for the mining company. How do they actually go about it? Let's take a look at the methods of extraction. There are 2 main types of mining, surface mining and subsurface mining. As the name suggests, surface mining is used when the mineral is either exposed on the surface or only covered by a small amount of rock or soil. This covering is referred to as overburden. Surface mining can be further categorised into open cast mining, which is sometimes referred to as open cut or open pit mining, and strip mining. Subsurface mining is much trickier as the deposits are covered by deep layers of unwanted rocks, and it involves digging large access tunnels underground to access the resource. Subsurface mining can involve deep mining, drift mining and shaft mining. Let us take a look at these in more detail. In surface mining, any overburden is first removed. The open pit mines are often dug in sections called benches. They are dug at angles to help keep the land stable and prevent rockfalls. Examples of open pit mines include quarries for building materials such as sand and gravel. A common example of strip mining is for the extraction of coal near the surface. Often large machinery is used to extract a seam of coal in a long strip. Subsurface mining is much more difficult, costly and risky. It involves digging deep tunnels under the ground to access the mineral deposits. Horizontal tunnels can be dug into the sides of mountains to access coal seams. This is known as a drift mine, and access is via an adit. Deeper deposits can be accessed via a sloping tunnel that allows access for the workers and machinery. However, very deep deposits can only be accessed via a vertical shaft, and this is known as shaft mining. In summary, rocks and minerals provide us with the basic building blocks of nearly everything around us. Geologists search for these deposits through a process called prospecting, which could just involve looking at the rocks on the land. More technologically advanced methods include remote imaging, perhaps from aerial photographs or satellite data. Geophysics involves using seismic waves over land or sea and generating a picture of the rock composition deeper in the earth crust. Field surveys follow, where rock samples are taken for geochemical analysis. Resource evaluation takes place next to see if the mining companies view the deposit as economically viable for extraction. Once geologists have identified a deposit, the method of extraction will involve either surface or subsurface mining, depending how deep the resource is in the Earth's crust. One thing all forms of mining have in common is the impact on the environment caused by the extraction. In our next video, we will be looking at the impact of rock and mineral extraction, how it can be managed, and how it can be performed in a more sustainable way. I hope you found this video helpful. Bye for now.